stop sharing. I'm going to share with you. A slide. This one. Before I try to solve couple of equation. I think we stopped at the example earlier. So I'm going to recapture things that we have learned in this topic. So perhaps I might start with open one of the file here. Hold on here, my template here. Yes, open up another file here. So I'm going to open up another file, my working template. So I'm going to focus on this one. Yeah, you have the blank display or blank template, correct? My working template. Yeah. So what I intend to share with you now is just to to recapture what we learned in balancing or reciprocating engine. One will be even you know well that there are a couple of type in engine. Yeah, one is 2-stroke and the other one 4-stroke. But for this type of engine, which is we call it the radial engine or the V engine, it is not concerned about whether it belongs to the 2-stroke or 4-stroke engine. So the crank position typically start with the crank position. Yeah. So crank position. Yeah, this one is crank position. Remember, the crank position is typically theta. Yeah. So it is no longer what you earlier is equal to 720 by n, and the other one is theta equal to 360 by n. This one is the 4-stroke engine. This one is for 2-stroke engine. This is belong to the inline engine. Inline engine. ENGINE. Yeah. We are not going to do this one anymore. We are not going to do this one anymore. Okay. So for the radial engine, the theta is basically 360 by n. It doesn't matter belong to 2-stroke engine or perhaps it is belong for 4-stroke engine, but very what we call it generally we know that the radial engine typically meant for 4-stroke engine, which is very high capacity engine. 2-stroke engine will give you problem like in complete combustion. So this one is typically 4-stroke engine. It will not be considering whether you have defining order or not. The reason is why I will tell you later. Yeah. So this is theta. The reason why you have 360 here, because the arrangement of the engine is in one circle, isn't it? It's one circle. If I can go back to this one, look at here, this one in one circle. So what does it mean? So it simply means that the arrangement of the engine will be in one circle. So there is no what displace, or sorry, there's no space between one cylinder and cylinder. The space between cylinder to cylinder is basically by the theta. Theta is the equi angle. This one here, theta here. This one here. This one by theta here is the equi angle. This theta is not the crank again. This theta is the one is the space between cylinder number 1, number 2, number 3, number 4, perhaps. So this is theta by 3 and 4. Okay, so that is one. Yeah. The other one that you have to understand that, so you don't basically looking for firing order. This one you need firing order. It's a compulsory. This one say must firing order. Astaghfirullah. It's not PO. Yeah, it's a FO. Firing order. It's compulsory. This one not compulsory. Not compulsory. Even you don't need one. Don't need this. The reason is why, as there is no space between cylinder, isn't it? So what you have is only, remember, you have summation of F equal to M omega square R, or perhaps can also be written MR omega square. You have another one, M equal to, you have M R D omega square. So this one becoming 0 as D equal to 0. So what you have is basically only force. This one only force. Only force, isn't it? Of course, you have the force secondary and force primary. You have force secondary. You also have force primary. Of course, primary come first before secondary. Yeah. Okay. So you don't need to find out on this. So what you have to do now is no construction of what? No construction of what? No construction of anyone? Of polygon. Okay, no, yes, thank you, Eva. Yeah. So no construction of polygons. What you have is only Krang what? Krang diagram. Remember that Krang diagram. Okay. So now we start. So by applying direct and reverse Krang, we can predict or perhaps estimated the balancing. 1 minute, yeah. So many files open here, so I've been disrupted by all files here. So estimated by applying direct and reverse Krang. What is direct and reverse Krang? We'll explain you later. Krang, we can predict estimated the balancing of the engine. The balancing of the. So the problem now, what is the direct crank and reverse crank? We already know that. We know it's crank diagram now. We know that theta is equal to 360 by n. Doesn't matter what type of engine we're dealing with, isn't it? The other one is what is the direct and reverse crank. So now we go back to our figure now, or go back to our notes here. So go back here. Oh, this one is inline engine. Sorry, I opened up the wrong file here. So I'm going to open up the correct one. So the correct one will be cancelled. The correct one will be open up the wrong file basically. Yeah. Here you are. Okay, now this one's the correct one. This one, yeah. So what is direct crank and reverse crank? So this is the reverse crank and direct crank. Look at this one very careful now. Reverse crank. Look at the direct crank and reverse crank. Okay, the direct crank is basically the actual crank of the engine, the actual one. So the reverse crank is the image of the direct crank, the actual crank. So what is the image? It simply means that it will reflect at 180 degrees when you put a mirror along the this one is line of strokes. You put a mirror here. This is the M now. It will be reflected here. But when you have an M here, it is no longer M. It's becoming half M because you have two crank. One will be the actual one. The other one will be the virtual one. So this is how we are going to apply on direct and reverse crank. Okay, so then you know what the direct and reverse crank, because most of the problems typically start with what you understand by direct and reverse crank. Okay. Okay, now then the procedure. This is the procedure. You might not be memorizing all the words of the procedure. What I tried to say here is you need to what? You need to pick up on the keywords. So the keywords say here. Keyword, yeah, keyword. The keyword, yeah. The keyword, put it keyword. K-E-W-O-R-D. Keyword is, look at it, from line of stroke to common crank. So that is the major keywords. For example, yeah, primary direct crank. You measure from where? From line of stroke to where? To common crank. Then following the given direction, because you're talking about primary, for example. If the direction has not been given, for example, you can assume the direction could be clockwise or counterclockwise. Same thing for the reverse. Measured from the line of stroke to where? To common crank. But remember, this one is reverse, so it must be what? Opposite direction. So you don't have to remember the word by word of the procedure. The other one is we're talking about secondary crank diagram, for example. So same thing, measured from line of stroke to where? To common crank. But now, because you're talking about secondary, it must be twice. And last but not least, you're talking about secondary reverse, from line of stroke to common crank now. It is still twice, but opposite direction. So these are the procedure it is, we will going to put this procedure in our crank diagram. So how is it? We start with doing example. Before that, I would like to share with you a couple of things here. The equation. The initial, typically forces, exactly the same as what we have in the inline engine. One will be the secondary forces, the other one will be the primary forces. This is the secondary forces. This one will be the primary forces. It's exactly the same. The new equation will be, we have N here. What is N stand for? N will stand for number of cylinder. Okay, number of cylinder. This one, same thing, we have N here. So the other term or the other variable of the equation is exactly the same as what we did earlier. So the equation now coming from what? Coming from the initial, where you have the F, we call it the unbalanced, isn't it? Equal to M omega square R cos theta plus M omega square R cos 2 theta divided by N. So this is the equation now. Only when you pick up for a specific parameter, for example, because this one is the primary, this one is secondary. You know that your primary, you have two, remember? We have F primary direct, we have F primary reverse. Same thing here. F secondary direct, F secondary reverse. Then you have the equation as such as F primary direct is equal to divided by 2. This one is omega square R. Then you have cos theta. This cos theta is the position of the crank itself. So this is the magnitude, remember? This one is the direction. Position, because we are dealing with vectors. This one is magnitudes or value. Magnitude plus position will give you vector. Okay, let's start now by doing an example. A good example is what you have here in your notes on page 143. You have the results on your notes. You can pick up, you can turn to page 143. No? Anyone would like to ask anything? Anyone? Are you still having your holiday, or you are now with me? No, thank you, Lee. Yeah, thank you, Lee. Some of you keep asking about your status in the status mark for test 1. Yeah, very unfortunate at the moment now. My colleague have not finished the marking all the papers. So I will let you know as soon I get the results. Okay. So at the moment, don't ask when it will be displayed for your first test. Yeah, for your first work on your test. Yeah. Let us now focus on what we have for the future test, second test. Okay. So now what you have here is you have. I'm not going to read the whole thing. Yeah. What I'm intending to share is basically describe here the methods by which such forces may be balanced. So first you need to define what are the things which is not balanced. Then you are going to solve, or perhaps you are going to balance the engine. Okay. So first start with this one. No doubt about it. You will have 360 divided by 4. Why 4? Because you have 4 cylinder. Okay. This is the crank diagram. Because the crank will be rotating, and you know well that as in radial and also V engine, you have only a single crank, what we call as common crank. CC is a common crank. Some call a single crank. Same thing as the V engine. That's why you have the direct crank and also reverse crank. So that's the intention saying that, or applying the direct crank and reverse crank, because you have only single crank. Then all the connecting will be connected to the crank, the single crank. Okay. So basically what we intend to do here is to construct the crank diagram of the motion of the crank. This one, the small circle here. So this is the crank diagram. Okay, now start with this one. You have the result with you. So this is basically just to share with you here, yeah, how it how it works. For example, I would like to share with you with is the one. So this is not the one. So I'm going to share with you the animation so that you have the idea, yeah, how the motion or perhaps how the movement of the engine. Let me get you the PowerPoint file. So I'm going to stop this sharing of the PDF. So I'm going to open up a new one. This one, so you have a very nice animation here. So you can visual how this engine operating. Huh? Of course, while doing balancing, you need to pause the engine. Huh? This one. Look at here. So this is the movement of the crank. So the green one, or the foregreen is representing the connecting rod. A single green here, which carry all the connecting rod, is the crank. Okay, and the piston 1 up to 4 is reciprocate along the what you call it, the line of stroke, or perhaps from TDC to BDC. Of course, the activity will be induction or suction, compression, power, and also exhaust. So this is the animation, and this one be the what you call a schematic diagram. Sometimes the schematic diagram is not as what you have this one. Only a line representing all the cranks. So you have this one. So I'm going to basically draw the small here, the small circle here. Okay, so now I'm going to stop sharing this one, open up the other file just now, the early file, so that I can write something on the screen. Okay, now, so this is numbering of the engine. They provide you 1, 2, 3, and 4. And remember, the rotation is counterclockwise from your seat. This one is given. They need to provide you this one. So we're going to construct one primary direct crank, primary reverse crank. This one for force primary. The other one will be secondary direct crank, secondary reverse crank. This one for F secondary. So the actual force on the system will be the resultant between the force generated by the primary and also force generated by secondary, of course, in vectors. Okay. Okay, now I'm going to change the slide. This is the result. Look at the results. You have this one, yeah? So now, okay, now I'm going to construct a working here so that you can see and you can easily understand how it works basically. So look at here. This one is the crank, the position of the crank. 1, 2, 3, and 4. Crank located at cylinder number 1. And the rotation is counterclockwise. Right. So then you have the primary direct crank diagram where theta is equal to what just now? Theta equal to 360 by 4 will give you 90. So this one is 90 degrees. Then this is your results. And this is the direction. Okay. So what is the procedure tell us just now? It just mentioned that measured from the line of stroke. So we move or we perhaps refer to the given diagram here. So this is line of stroke. So measured here, two common crank. Is it? Common crank for cylinder 1. So cylinder 1 becoming reference. Then cylinder number 2 move. Cylinder 3 same thing. Measured on line also two common crank. So everyone will fall at common crank. And everyone will fall at cylinder number 1. The next one is 3. Astaghfirullahalazim. 3 and 4. Sorry, guys. This one is 3 and 4. Balance known? It is not balanced because everyone pointing at cylinder number 1. So it is not balanced. It can also be presented if you construct a polygon, perhaps, you will have a polygon, every polygon or every line will be pointing upwards. Then you have to bring back the line, so that will be the unbalanced parameter. So perhaps in other words, if you put it in the equation, You have F primary direct is equal to N just now. Then we have M omega square R cos theta, not to forget divided by 2 because you have 2 crank now. You have cos theta here, isn't it? So how do you manage, or how do you get rid of cos theta here? And we assuming that this one is this. So cos theta now is equal to cos 0 is equal to what do you have for cos 0, class? What do you have for cos 0? 1. So this one is suddenly vanished. So you have only the first part of the equation where will give you this one. Okay? Any question? Then we move. This the first diagram is the easiest one. Let us now move to the second one. This one, yeah, primary reverse crank. So how does we get the results here? So now this is working. Number 1, number 2, number 3, number 4. Crank here, and let me change color so that you can differentiate the results here. So this is the given direction, omega. Then this is your answer. This is your equation. This one is your answer. Of course, in test you don't have to do this one. I just want to explain to you how it works. Yeah. So now because the crank located at cylinder number 1 will become your reference. And this one is no longer rotating counterclockwise. It will be rotating clockwise because we are talking about F primary reverse. Or this one is primary reverse crank, isn't it? Crank, where you have theta equal to negative 90. Negative here because it's rotating opposite direction. Huh? Okay, so now, so if 2 now move 90 degrees, following the given direction, remember for the reverse, it also moves 90 degrees but opposite direction. So instead of moving counterclockwise, it will move clockwise, negative 90. So 2 will be here. Correct or not? Correct or not? Yes or no? Yes or no? Okay, now, thank you. Yeah, okay, now, look at cylinder number 3. I do this one after another, yeah, so that you can easily understand. Okay, now 3 will move 180, isn't it? Following the given direction. But now we are talking about one reverse. This one is omega reverse. So you will also move 180, but instead of give you negative 180 here. This one is positive. This one is negative. So you will have number 3. Correct? Number 4 now. 1, 2, 3, 4. Okay, number 4 is here. So crank is still here. Measure from where? Line of, this is the line of stroke. Measure from line of 2 common crank. The procedure. This is the given one. But now we are dealing with the reverse here. So it will be rotating clockwise from your seat with the same what? Magnitudes. What is the magnitude? 270. Now this time around, it's very difficult for us to check where well the 70 is. So now we start counting segment. How many segment? 1 segment, 2 segment, 3 segment. So now we are also now move 4 segment. So 1 segment, 2 segment, 3 segment. So 4 will be here. Okay? Correct not? So we go back to the result where it's correct not. We found that 1 and 3 at top, 2 and 4 at bottom. 1 and 3 at top, 2 and 4 at bottom. Now it is balanced. So if you construct the polygon perhaps, yeah, you construct the polygon, you'll be getting what? You'll be getting such a nice polygon. You will bring back to the original line here, isn't it? This one is 1 and 3. And 4 be 2 and 4 pointing downward. 2 will be here, 4 will be here, and it will be what? It will be closed polygon. And it becoming 0. So your result now, remember, your F primary equal to F primary direct plus F primary reverse. Of course, in the vector, you add up together, you bring this one. Any question? Any question? Any question, Mon? Thank you, Kao. Yeah? Okay, now I'm going to move to the next one. which is a bit challenging compared to the first one. Then when I do couple of example, I will make a conclusion regarding the diagram. Yeah, look at this one. This time we're going to construct secondary. What does it mean for secondary? It means that from theta we move to 2 theta. From 90 we move to 180 degrees. It doesn't matter whether positive, negative. Yeah, just move twice from the primary. The equation will be doing the same thing, only you divide it by n. What is the n? N is basically the ratio of the connecting rod and the length of the connecting rod and the radius, crank radius. Okay. So now I'm going to how do we get this one? So look at there very careful. Now this is the equation. 1, 2, 3, 4, and crank will be here, rotating counterclockwise from your seat. And this is the prime. What do you call it? This one is secondary direct crank, where your theta is equal to 180. Right? Secondary direct crank, your theta will be 180. Sorry, it's not your theta, your 2 theta. Okay, so this is the result. Don't we just put divided by 4, doesn't matter. So as we found that the common crank fall is cylinder 1, so cylinder 1 become your reference. Because what you measure at the same position to the same position, meaning that you measure from the Lighthouse stroke to common crank. The common crank and the common crank and the Lighthouse stroke will fall in the same position. Okay. So now, cylinder number 2. Okay, this is the secondary direct twice 2 omega now. Cylinder number 2 move. Let me change the color here. Cylinder number 2 will move what? 90 degrees for primary. For secondary, you have 2 here, isn't it? So now we'll move 2 segment, right? We will move 2 segment, correct or not? So we'll move here. 2 segment. Number 3, initially move 2 segment. So you will move how many segment? 4 segment. 4 segment to comply the procedure. So number 3 will be here. Number 4 a bit, many segments, so we put up a 4 here. Number 1, number 2, number 3, number 4. This is the crank now. 4 now. Focus on 4. 4 move how many segment? 3 segment. But now we are talking about secondary. So it move how many segment? Another 3 segment. It becomes 6 segments. So we have 1, 2, 3, 4, 5, and 6. So 4 will fall here. 4. Balance not, it is balanced. So if you construct a polygon, for example, even though the question doesn't ask you to construct polygon, you'll be getting a very nice square. So it is a closed polygon anyway. So if we go back to the result, you will have a very nice results here. So it becoming 0 as the system or the engine is balanced on that particular parts. Okay, now we move to the secondary reverse now. Same thing. From 180, this one is not theta, this one put it at 2 theta. I think your book is correct. This one is my very many years notes. This one is 2 theta again. You have 180, this one you have negative 180. It simply means negative if you're not rotating anti-clockwise, if you're rotating counterclockwise, clockwise. So look at this one. So I'm going to share with you another solution here. Now, this is the working, or this is the, the equation. Number 1, number 2, number 3, number 4. Exam and test, don't do this type, This one just to ensure that you understand. So this one is early given here, omega. This is your results. Remember, your result is secondary reverse crank, where your theta is negative 180. Then you have a results here. This one will be reversed. You'll be getting 2 omega. So 1 will be located here because the crank and also the common crank fall, let's say number 1. So 1 will be your reference. This one put it here, reference. So cylinder number 2 now. 2 will move one segment if you are dealing with primary. If you are dealing with secondary, you move another segment. Instead of 90 becoming 180. But remember, for secondary, you also move to segment, but opposite direction. So 2 will move here. So it will basically that one. Number 3. So number 3 will move how many segments? 2 segments. Isn't it? Just start counting segment, yeah? 2 segments for primary, 4 segments for secondary, 4 segments for secondary. But we are dealing with reverse, so it be also rotating 4 segments, but now different direction. So be rotating 2 segments, another 2 segments. So you will basically go back to its own initial position. Number 4. I do this one, number 4. 1, 2, 3, 4. Crank will be here, isn't it? So how many segments does 4 rotate? 3 segments, primary, isn't it? And 6 segments for secondary. For reverse, also 6 segments. How does it work? So we put another color here. So look at here. So 1 segment, 2 segments, 3 segments, 4 segments, 5 segments, and 6 segments. 4B here. Balance on, it is balanced. It is balanced, yeah? It's balanced. How do you know balance? Because you have very nice position. If you look at the program, will display to you the example. Look at here. And this one is 0. So you add up together in vector, you get a 0 now. But remember, yeah, the initial of secondary and primary is basically what? The product of the on the engine itself. So you have the resultant here, you add up together, you have this one. So the unbalanced parameter is 1645 Newton pointing upwards. So this one is the unbalanced. So how do you want to balance? You want to balance because you know that from the very beginning, the crank is located at 1, isn't it? This one number 1, number 2, number 3, number 4. This one the unbalanced parameter with the units of 1645 Newton just now. So you turn this unbalanced parameter to become your what? If this one F equal to M omega square, for example, you know that the MR is basically multiplied by the omega. This one is constant. So you make another MR here. Then this one is what call it is balancer or counterbalance or countermass. So the system is now balanced. What is the magnitude? The magnitude will be, it is pointing upward with the units of 1645 Newton. This one will be pointing downward with the unit of 1645 Newton. So now the system is balanced. So in the real engine, how does it work? It will be I think I have this one. Look at here. So assuming this one, imagine this one only 4 cylinders, yeah? This is the ducted one, this one. This is the unbalanced parameter. Okay, look at here, the counterweights. This one also the counterweights. You can put the counterweight by 2-sided, front and the rear, or you can put only 1-sided, it doesn't matter. You add up together, will bring you the summation of the counterweights. So that is the conclusion, Okay, any other question before we move to the next one? I'm going to share with you not the 3-cylinder, because you have the next one with 3-cylinder, which is not very difficult. Any question before we move on? No, okay, thank you. So I'm going to move to 3-cylinder. So basically, if I can share with you another time, yeah. Let me. Okay. Let me 1 minute. Yeah. I'm going to stop sharing here. I'm going to share with you the animation just now, which is very interesting. Isn't it? Look at here. How does it balance? So look at here, this one. Can you see the animation class? Do you get the animation displays? Animation display. Do you get the animation display? Yes, thank you, Lisa. Look at here, the blue one here. This one, if you can see my cursor here, the blue one 2-sided is the counterweight. This one, the green one, the other side is also counterweight. This one also the green one, the other side is counterweight that you calculated for 5-cylinder, for example. Of course, just now we are dealing for 4 cylinders. Okay. So if the system or the problem asking you how to balance, so this is the way how to balance. The procedure is what we did earlier just now. The magnitude is one, if you're talking about 4-cylinder just now, is 1465 Newton. Huh? Okay, so I'm going to stop sharing this one. I'm going to share with you the earlier part, this one. So I'm going to move to after this one, you have cylinder, 3 cylinders in it. Correct, not? 3 cylinders is not very difficult. So if you go to your notes here, if you can look at your notes here. This one, you have one minute. Where are you? Completed this one. Completed this one. We completed this one. So your notes, this one, yeah. 3 cylinder is not very difficult. I'm not going to do this one, huh? So I believe that you can do this one. Just as I mentioned just now, I'm going to give you what do you call it? The conclusion. Look at here for 3 cylinder. So your theta is up. A very quick one, class. Look at here. So your theta is equal to 360 divided by n. Of course, your n will be 3 cylinders, so that will give you 120. So the arrangement will be as what we have here. So we are going to construct this one, a small circle here. So you will have as such this one. So how does this work? Look at here. 1. Cylinder number 1 is at top, then left and right. Yeah. Number 2, 1 at top, then left and right, clockwise from your seat. Okay, so how does it work? It's basically now for cylinder number 2, for example, yeah. For cylinder number 2, we'll move how many segments? 2 segments. Oh, sorry. I'll stop one thing. Cylinder number 2 is 1 segment, which will give you 120 each division or each segment. Is it measured from line also to common equation? 3, the same thing, 240 now. Line of stroke to common equation. So we will have this one. Balance not, it's not balanced. How does the cos theta become cos 0? Because we are, we say that this one will be 0 degrees. So the cos theta will be cos 0. So it's cos 0 equal to 1, as you mentioned earlier just now. So you have numbers here or value here. 7, 8, 9, 6. So now how does it work this one? Okay, go back to here. Okay, now this is your work. As been given here, look at here, as begin here, the crank is located as number 1. Isn't it? So cylinder number 1 becoming your reference. So 1 become your reference. Number 1 reference. Then number 2 is here, isn't it? So 2 now, put it here. 2. Okay, I do you here. The what call it? The working. Astaghfirullahaladzim, sorry, yeah. The 4 cylinder is this one, isn't it? So is this one in construction? Yeah. Okay, now it's 1, 2, and 3. Here. This one just now, primary direct. We move to primary reverse. Reverse, simply see that you have this omega. This one will remain as it is because this one is reference. How do you know reference? Because the crank located at cylinder number 1. Okay, now how are you going to do cylinder number 2? Look at here. So now, so cylinder number 2, basically it will move here just now, isn't it? Only 1 segment, correct? Which bring you 120. Am I correct? Now it's also move 180 but opposite direction or reverse. Negative 120. So will fall here. Fall here. Understand or not? Isn't it? Okay, look at number 3 now. Look at number 3. I'm going to change another color here. Look at number 3 now. 3, move how many segments? From measure to line also 2 common equation, you move 2 segments, which will bring you 240. Now you're also working 240 but opposite direction. So 3 will be working 240, 1 segment, another segment. So you have here. Balance not, it is balanced. If you construct polygon, it becomes a very nice triangles. That is why 0 here. Then you add up together in vectors, of course, you get the result here. This one is also not very difficult. This one is secondary direct. How does it work? Number 1, number 2, number 3. This one just now rotating here, omega, given, isn't it? So now omega. Number 2 rotating, this is reference because the crank fall on cylinder number 1. Number 2 move 120, one segment. Now it is no longer one segment because you're dealing with secondary. It will move 2 segments. You move 2 segments, we'll move another 120. So 2 here. Understand me or not, class? Is that clear? Hello? Yes, thank you. Thank you, Ariga. Yeah? So number 3 now. Number 3 will move how many segments? Number 3 will move 2 segments upon reaching common crank. Measured on line of 2 common crank. Now it becoming 4 segments. 1, 2, 3, and 4. 3 will be here. Balance not, it is balanced. It's balanced. Okay, look at here. Then I make conclusion before we move to 6 cylinders. Okay, now you have 2 omega. This one. Cylinder number 2. So if I can clean up here. Okay. Now, cylinder 1. So move to cylinder 2 now. You move 1 segment for primary, 2 segment for secondary, direct. Now also 2 segment but reverse. How does it reverse? It will reverse. Oh, sorry, this one is not correct. Yeah. Sorry, this one's supposed to be another direction. The other direction. This one is 2 omega. This one now. So you have 1 correct, 1 segment, another segment. Cylinder number 3. Focus number 3 now. I can clean up this one. Just measure the segment because you know that the segment is equi-segment, yeah? It's equal. So number 3 now. We move 2 segments for primary direct, 4 segments for secondary direct, 4 segments for secondary reverse. So how does it work? So 4 segments, 1 segment, 2 segments, 3 segments, 4 segments. Balance not, it's not balanced because everyone will be pointing at 1 cylinder. Everyone meaning that every force here pointing 1 cylinder. So it was not balanced, so you have the result here. This cos theta become cos 0 because we think this one as 0 degrees. Then you have numbers. Then you add up together. So that will give you this one. So these are the number that you have to balance. About 10.5 kilonewton, pointing upward. Okay, so if you want to balance the engine, for example, yeah, right from the given engine, what you have here. Okay, I clean up this one. So you are going to make a balancer pointing downward because everyone just not pointing upward, not pointing down. So the system now balanced. Okay, so to ensure that you understand this one, I'm going to give you a 6 cylinder. 6 cylinder. Okay, now 6 cylinder. Theta is equal to 360 divided by 6, which will give you 60 degrees each. And let's see that the arrangement of the connecting rod is what you have here. 6 cylinder, yeah? 2, 4, 6, right? So be 1, 2, 3, 4, 5, 6. Let's say you have this one, omega. And the what do you call it? The angle between cylinder to cylinder is 60 degrees each. So we are going to construct now primary direct crank where your theta equal to 60 degrees. Are you with me, class? Hello? With me, I have what? I have 45 engineer, yeah? Engineer to be, inshallah. So now, yes, thank you, Tan. Thank you, Ahmad, yeah? Okay, now. So how are we going to do this one? Okay, now. Listen up very careful. Listen up very careful. Yeah, I'm going to write something this one. This is my conclusion. Yeah. For primary direct crank, always not balanced. Always not balanced. Always not balanced. Okay, so you don't have to do the primary direct counting how many cylinder you have. Just put it here, always not balanced, and located or position at the common crank. What does it mean? It simply means that if I start constructing this, what do you call it, the primary direct crank, this one is 2, 4, and 6. I don't have to do anything about it. I'm going to put it in 1, 2, 3, 4, 5, 6. That is what I try to make. That is what I try to say with you. You understand me or not? If you have 12 cylinder, for example, you don't have to do this one, this 12. You just put 12 cylinder, fall at cylinder number 1. The reason is why the equation gives you 1 will be the location for the crank. So this is also the common crank. You understand me or not, for example, class? If the common crank fall of 4, for example, so everyone will fall at 4. Hey, understand me? Is that clear? Yes, thank you, Masilako. Okay, now. So how about the calculation now? The calculation is basically F primary direct is equal to, remember the N, this one is M omega square R cos theta, not to forget divided by 2, yeah? Then you have this one, N will be 6 cylinder. This one be M will be M, omega be omega, is constant parameter divided by 2. This one is cos 0 because we are putting 0 at top or at the vertical plane. So you will have this one 3m r omega square Newton pointing upward. The result. Any question? Okay, now we are going to construct what? We are going to construct primary reverse crank. Primary reverse crank. Theta now is negative 60. How is it? Put it here. This is your working. Of course, in test and exam, you don't have to do this one. I do this one a lot, isn't it? Just to ensure you basically understand. Yeah. It is very difficult. It is very easy to understand. Yeah. But when you go back, or perhaps when you are alone, yeah, it's very difficult to bring back what we learned in class. Yeah. So now this one is 2 just now is rotating this way, omega. So this is the result. Same thing, 2, 4, 6. 1 will be here, as the crank will be located at 1. Then you use this one, and this one is rotating the other direction. You use this one. So now, cylinder number 2 just now. How many segment does it goes? 1, 2, 3, 4, 5, isn't it? 1, 2, 3, 4, 5. Correct, not? 5 segments. So now it's also go 5 segment, but opposite direction. So if I can put another color here, let me put another color here. So we'll move 1, 2, 3, 4, 5. From here, zap, fall here. Cylinder number 2. You get me or not? Number 3 now. This number 6 is the easiest one. Look at number 6. 6 move 1 segment. Correct. So it will move move 1 segment opposite. 6 will be here. Correct or not? Number 5. Also the easiest one. Number 5, move 2 segment. Then we'll also move 2 segment. Number 5. Number 4. Could anyone tell me where number 4 is? Number 4 move 3 segment. So it also move 3 segments. So where will be number 4 now? Number 4 will be here. Correct, not? This one is so obvious. It's becoming number 3. Just prove it. Prove it number 3 or not. I'm going to put a number 3 here. I'm going to put another color. So number 3. How many segments you go? 1 segment up to here. 1, 2, 3, 4. So you move also 4 segment. 1 segment, 2 segment, 3 segment, 4 segment. Number. Understand you're not, class? Understand, no? Hello? Thank you. Yeah. So now, balance not? The balance. What does it mean? It simply means that your F, this one is primary, reverse is equal to 0. So you have add up together for primary, primary, yeah, equal to 0 plus F. It's not 0. Just now you have 3 something, isn't it? You have 3m omega square r plus 0. So you add up together, so that will give you 3m omega square r Newton pointing upwards. So that is the result for primary. And you have another diagram for secondary. So any question before we move to secondary? Any question? So now secondary. Secondary, yes. Secondary. Not very difficult. Secondary is here. Zap. This one is this is the equation just now. Number 1, number 2, number 3, number 4, number 5, number 6. Crank is here. Direction, this one, clockwise from your seat. So secondary direct crank, your 2 theta is equal to 120 or 2 segment. So this is the results. 2, 4, 6. 1 here. Reference. This one put it here. This one is your reference. Could anyone tell me why this one want to be referenced? Anyone? Otherwise, I'm not going to solve this one. You don't respond and answer my question, so I will leave it at that, and you have to do on your own. Because of crank, because common crank. The correct one is because the common crank fall less than number 1. Okay, so that is the answer. If supposingly, let's say supposingly, suddenly you found that you have a very nice engine here. Let's put this at 8, for example, yeah? 1, 2, 3, 4, 5, 6, 7, and 8, and everyone before at 45 degrees. And you found that the crank fall at cylinder number 1, or the crank will be located or positioned at number 2. How are you going to start? How are you going to start? Solving is one method, start is one other method. How are you going to start? Anyone, you don't answer this one, I will leave it like that. So set to reference. Okay, set to reference is not correct. I think I already discussed this one in my first lecture. Push it to number 1 is correct. Correct, yes. Push it number 1. Push it vertical, correct. So you can push it vertical easier, or you can push it horizontal. Number 3 also can. So either number 1 or number 3 can. So if you put this one, very difficult for you to calculate all the component of forces. Very difficult to look component of forces. Remember that. Sometimes in books, it's not in book. You put it here somewhere not somewhere along the position along the cylinder. It might put it here. It might put here. So it doesn't matter. Just push it on vertical or horizontal. Vertical is better still. Yeah. Okay, now come back here. So you have start with number 2 just now. This one is the secondary direct crank. So you have 2 omega. So cylinder number 2 just now move how many segments just now? 1, 2, 3, 4, 5. It becoming what? It becoming 10, isn't it? So 10. 5, 6, 7, 8, 9, 10. Number 2. Number 6, the easiest one. Number 6, move one segment for primary direct. It moves segment for secondary direct. So number 6 here. Number 5, move for a 2 segment. Isn't it? 2 segment for primary direct. Secondary direct, you move 4 segments. So you move another 2 segment. Number 5. Number 4, you move how many segment? 3 segment. Zap, 3 segment. It becoming 6 segment. Another 3 segment. Will fall here. This one number 3. Proof, it will fall here. Number 3, move 1, 2, 3, 4. It becoming 8, 5, 6, 7, and 8. Balance not, it is balanced. So your F secondary direct equal to 0. Okay, we move this one, secondary reverse. Any question? Upon this one, any question? Any question? Any question? No, thank you, Ahmed. So we move to secondary reverse. Now, secondary reverse crank, which you have 2 theta equal to negative 120. Is it 120? Correct, yeah? Just now, positive here, now it's negative. Just tell you that the negative will be the opposite direction of what you've been given. Huh? So now, your equation 2, 4, 6. You have 1, 2, 3, 4, 5, 6. This one is your reference to provide you as such. So this is the result now. This is our secondary direct crank. This one, yeah, is 2 theta equal to negative 120. Oh, it's correct. 6, yeah. 1 reference, isn't it? So now, number 2 move how many segments just now? 5 segments, isn't it? 5 segments, isn't it? 5 segments. Okay, 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5. For primary, secondary 10. Secondary direct 10. Secondary reverse. Oops. Astaghfirullahaladzim. It's not correct, yeah? This one is secondary reverse. So you have 2 omega. So secondary reverse will have also 10. So how does 10 goes? Yeah. So now, number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 2 here. Correct not? Start number 4, number 6. Number 6 is the easiest because only 1 segment. Then you have 2 segments. Then you move only another 2 segments here. So this one number 6. Number 3. Start the number 5 instead. Number 5. How many segments you have? Number 5? 2 segments. So it becoming 4 segments. 4 segments. Reverse, yeah. 1 segment, 2 segments, 3 segments, 4 segments. Number 5. Number 4. How many segments? 3 segments. Become 6 segments. Reverse 6 segments. 1 segment, 2 segments, 3 segments, 4, 5, 6. Proof number 3 will be here. Proof this one number 3. Correct or not? Number 3, 1, 2, 3, 4. Becoming 8 segments. So 8 segment reverse, yeah? 8 segment reverse. So you put 1, 2, 3, 4, 5, 6, 7, 8. How do I go? Where do I go wrong? Put it another time. It's already very tedious there one, isn't it? Okay. Number 1, number 2, number 3, number 4, number 5, number 6. Number 3 now. This one is, 3 is 1, 2, 3, 4, becoming 8, isn't it? So now becoming 8 reverse. Okay. 1, 2, 3, 4, 5, 6, 7, and 8. It's not 3, correct. Balanced knot is a balanced one. So this one balanced, this one also balanced. So you found that your F secondary is equal to 0. But it's not end up to that, yeah. Basically the F, we are looking for F now, summation of F. So equal to F primary plus F secondary, of course, in vector. So finally, what you'll be getting here is 3m omega squared out just now plus 0. So your force total force is basically 3m omega squared out, Newton pointing up. So these are the results. Any question? Before we move to the next one, yeah, we're going to move to the V engine. Any question? Okay, Marcella, thank you, Marcella. Cool, thank you, cool. So I'm going to move now to the V engine. So hopefully you understand about the thing that we discussed here. You can do on your own this one form. This one is 11, 12 cylinder. So imagine that if you do not count the segment, very difficult for you because you have what? You have theta here is equal to 360 divided by 12. You will have 36 degrees, isn't it? Yes or no? Yes or no? Yes or no? Yes or no, class? What do we get for 12? 360 divided by 12. Anyone? Yes or no? No, it's 30 degrees. 30 degrees. So imagine you have 30 degrees. 30, 30 is very difficult for you, isn't it? So start counting segment because you know that the segment or the angle is the equiangles. Yeah, the acute angle is one all same. Okay, now I'm going to move to the this one. This what we call the sorry, I'm putting the wrong button. The V engine. Before we start this one, I would like to stop sharing this one. I'm going to move to share with you the animation just now so that you can see how the motion of the V engine comparing with the radial and also inline engine. Look at this one. So this is the V engine. Look at here. As I mentioned earlier, if you remember in my first lecture, I did mention about for the V engine here, you know that V engine has so many cylinders. I totally agree with you. And you know that the crank, it is not crank but crankshaft. This is crankshaft, like very similar with the inline engine. But as you know that the connecting rod and the cylinder and also the piston are identical for everyone. So it simply means that even though you have so many cylinders, you can focus only one bank. The reason is why one bank carry 2 cylinders. Remember that one bank carry 2 cylinders. Bank is B-A-N-K. So for example, here you have 6 cylinders. So first bank will be carry cylinder number 1 and cylinder 2. If you have 8 cylinders, for example, you will have how many bank? If you have 8 cylinders, how many bank you have? How many bank? Anyone? 4 bank, yes. Yeah, 4 bank. So even you have so many cylinders, just focus on one bank only, which carry anyone. If you are talking about you want to focus on bank number 4, for example, if you have 8 cylinder, so you are talking what you have to refer is a bank number 4. It means that you're carrying cylinder number 7 and 8. So it doesn't matter, yeah. So you select only one bank, then you start doing the analysis. Okay, and with that, yeah, you know that because due to the what they call identical parameter for the whole cylinders, so you can representing the unbalanced parameter for the a bank to refer to another bank. Okay, so if you have one bank carry cylinder number 1 and 2, so the cylinder number 1, connected with connected with the connecting rod to a common crank. So now tell me, if you have a V8, for example, how many common crank you will have? How many common crank? Anyone? Hello? Just now I'm asking for your bank. Now it's common crank. How many common crank you have? Yes, 4, yeah? Because one bank, you have one common crank. So one common crank again connected or carry 2 cylinders. Okay? So now I'm going to stop sharing this one. I'm going to stop sharing this one. I'm going to share with you the PDF just now. So we will start it here. So before we start, let us overview what are the things that we're going to look for. For example, yeah, the same parameter we are going to look for. I'm going to share with you another file here. Blank, yeah. I'm going to share you another file. 1 minute, yeah. My working template, I'm going to share with you. Where are you? This one. Okay, this one, yeah. Okay. So here, what you have is equation being used is the F is basically same as what you have earlier. F is equal to F primary plus F secondary. If I may see this one, the resultant. And this one, you have two primary direct, primary reverse. Same thing as this one, also direct. You have two here. Secondary direct, secondary reverse. The keyword exactly the same. Keyword as in radial. The only different is yeah, the only different now is theta. Theta is no longer 360 by n. So this one cannot be used. So what is theta? Theta is basically the crank position. So theta now is, listen up very careful, theta is measured from vertical. From vertical, yeah? From vertical line, symmetrically to cylinder. What does it mean? Supposing you have this one. Symmetrically, yeah? So this one you have one. This one is V. What? We do not know because we have only two cylinder. We have V2. There is no V2. We call twin engine. This one, yeah, there is no V2. We start with V4. There is no V4. We start with V6. So this one we call twin engine. Because why we have two cylinders in V shape. So the V shape now we call V notch NOTCH in measured from this line of stroke to another line of stroke. So this is the V notch or V shape. Remember that V notch or V shape. V notch or V shape. Measured on line of stroke to another line of stroke. Okay, so if you have a such, for example, you cut into two. They call this one the V set at 60 degrees, for example. So you cut symmetrically, so it will carry you 30 degrees, another 30 degrees to each cylinder, cylinder number 1 and cylinder 2. So the crank will not be at or not. The crank will not at what any cylinder. It will always vertical. It can be vertically upward. It can also vertically downwards. So in other words, yeah, for example, if the crank now located at cylinder number 1, this one go further. It will be located here because now it's longer, isn't it? So you have to push this one to vertical or to vertical upward or vertical downward. Okay, so this one is the different thing that we learned earlier. So any crank will located not in vertical, push it vertical, then you do the balancings. Even in radial or in V. Okay, the other arrangement or the other procedure or solution is exactly the same as what we did earlier in radial. The equation is the same, the procedure the same, even the crank diagram are also the same. Okay, now you can turn this one on page 148. We have the solution video. I'm going to do this one. So look at here. This is the result. I'm going to share with you how do we get the results one. Okay, we can use remember just now, we can use the conclusion that the primary direct crank is always not balanced. So you put this one on the crank. It is no longer on cylinder, yeah? It is on common crank. This one, common crank. So if you want to do this one, exactly as the procedure tells you, so we have to do as what you have here. Okay, now this is common crank. This one will be the line of stroke. This one is cylinder number 1, cylinder number 2. Rotating end, they provide you the rotation just now is clockwise from your seat, clockwise from your seat. And this one we cut into 2 just now, evenly, symmetrically, becomes 60 degrees. So if you want to follow the keyword as what we did earlier, what you have to do is, this one is move 30 degrees. This one will move 330 degrees. Isn't it? Theta, you can do this one, theta, you can do this one, 2 theta. It simply means that this one will be number 1, number 2. Theta will be 30 degrees. This one will be 330 degrees. Okay, this one for primary, this one for secondary. So how do you balance? You just push this one, number 1. This one push this one to number 2, so it's not balanced. What will be the equation? Same thing. Equation if F is equal to, and this one is primary direct, and this one is M omega square R cos theta divided by 2, not to forget divided by 2, yeah. This one, what is cos theta to us? Cos theta is equal to cos 0, because we located this one at 0 degrees. It becoming 1. You have all the numbers. And finally, you'll be getting as such. Understand me or not? Okay, but it is easy for you that for any radial engine or V engine, you just put the numbers on the crank, on the common crank. How many cylinder doesn't matter. Okay, now we move to primary reverse crank. This one is something different from what we have earlier. This one is primary reverse crank. So the primary reverse crank is basically you have theta just now. It's no longer 30, becoming negative 30 degrees because it reversed now. So if I can share with you the arrangement of the working, this one your common crank, this one is cylinder number 1, number 2, given here clockwise. So this is the result. Crank. This one will be primary reverse. Other 30 degrees. So one move 30 degrees, correct? But now it is not 30 degrees because we are talking about reverse. So it will move 30 degrees but opposite direction. This one will be 30 degrees. 30 degrees, from the connecting rod, from the common crank, it becomes 60 degrees. So you have 60 degrees. Understand me or not? Yes or no? Anyone, could you please respond? You understand me or not? Yes, thank you, Leah. Okay, now. Thank you, guys. Those are responding. Thank you. Okay, now, number 2 now. I'm going to change this one another color so that you can easily see, yeah? Okay. 2 now. 2 just now move how far? It moved 330 degrees. Correct. 2 now move 330 degrees. So this time around also move 330 degrees but opposite direction. So we'll move 330 degrees. Complete circle will give you, this one is 360 degrees. What we need is only 330. So you minus by 30 degrees. Okay, then you have 30 by another 30. From this is the common crank, you will have another 60. This one all mathematics. You have to do a simple mathematics to calculate what will be the position for cylinder number 2. Agree or not? So now we are going to calculate this one. But remember, yeah, the calculation will be due to because the force is here. This is the force. This one is also the force. F2, F1. So you have to, this one is the actual force. You have to place this one on verticals. So you have to resolve this one. You have to resolve this one. So your calculation will be this one, yeah, you have to put here. So your F, this one is primary primary reverse is equal to, your equation just now is what you have, is the n, this one is m omega square r cos theta divided by 2. It is correct. But this time around, you need to know what will be the position for this one. So how are you going to calculate this one? This one is 2. This one is m omega square r divided by 2. Correct. But what about cos theta here? What about cos theta here? So this cos theta, remember this one. This cos theta is nothing to do with this one. It's not equal to that one. Remember that. This cos theta is nothing to do with this one. This cos theta is basically due to the unbalanced position of the cylinder. Okay, this one is due to the unbalanced position for this one. So if you're putting this one 60 degrees, for example, so you will have that cos theta is basically what? Is basically cos 60 degrees. Isn't it? Or you can also put this one 30, for example, yeah? You will have to do this one sine 30. Sine 30, yes, sine 30, correct. Remember, yeah, this cos theta is due to the, this one, put it here, due to the unbalanced position. It's not due to the theta that you provided earlier, due to the unbalanced. Understand me or not? Do you understand? Is that clear, class? You don't want to respond with mine, so next time you ask me, I also don't want to respond. Yeah, so it's payback time then. Huh? Yes, thank you, Tan. I will responding to those who are responding in class. Huh? Remember this one, yeah. Remember this one. It is nothing to do with the negative 30 just now. It will be what? It will be defining by the crank diagram. Okay, so at the end of the day, you'll be getting the results here. Okay, so pointing upwards. So you basically here. Okay, now let me ask you, what happened to another force? Because you have this one is you will have you have F cos, you have cos 60. You have another one, this one F sine 60. This one will be F sine 60. What happened to this cos? Sorry, what about this force? We call it axial force. What happened to the axial force? Anyone? Could anyone know? What happened to the axial force here? Hello? Balance, correct? It cancels off, cancelling automatically because both force acting opposite direction. It will cancel here, it will cancel here. So the axial force now is becoming 0 automatically. So that is the beauty thing on the V engine, also radial engine. Okay. So we move to the next one. This one is primary crank diagram. Okay, so we move to the next one. Yeah, this one now. This is the secondary direct crank. This is the result. I'm not going to do this one. I'm going to show you how it works. So this is the given equation just now. Crank position number 1, number 2 at 30 degrees, upon the connecting rod. Sorry, it's not connecting. Common crank rotating this direction. We are going to construct secondary direct crank, which your 2 theta now becoming 60 degrees. Isn't it? Becoming 60 degrees. In my book, I put here positive here just to share with you that positive will be holding what been given a position or direction. So this is the results. Crank, start with crank. This one now, the other, this one now is 2 omega. Then start this one is your working. Cylinder number 1 move 60 degrees. Cylinder number 1 move 30 degrees, sorry. Number 1 move 30 degrees for primary direct. For secondary direct, it will move another 30, isn't it? So becoming 30 and 30 becoming 60. Here now will fall here. Okay, cylinder number 2, it will move on. It will move 330 degrees. Let me change another color. Okay. For secondary direct, for primary direct, look at it just now. What you have here. This one is number 1, number 2, theta. This one is 2 theta. This number 1, 30 degrees. This one is 60 degrees. This one is 330 degrees. This one becoming 660 degrees. Isn't it? It's twice, isn't it? It's very difficult for us to construct 660 degrees. But easy for us to construct 720. Isn't it? 720 is 2 complete circles. So put it there, 720. So 720, so it give you 2 circles. 720 minus by what you need only 660, right? Minus by 660, it becoming what? 60 degrees negative, isn't it? So here is the 60 degrees. Yes, 60 degrees. Sorry, class, yeah. Not that. It should be 6 degrees. We are dealing with number 2. Yes, correct. 6 degrees. So we minus this one. Yes, we stop it here. Stop it here. 60 degrees. So it's lane number. Okay, because we start this here just now, we minus 60 degrees. 30 degrees. Balance not? It's not balanced. So what will be the calculation for the unbalanced force? The F is equal to, this one is primary, secondary direct. We have N, this one is M omega square R cos 2 theta divided by 2, isn't it? So this is the equation that we have earlier. But remember, as I mentioned earlier, this one is the equation that from the theory. What we're doing now is to what? To balance this one. So you might not be use this one cos 2 theta. You put it here in just cos, whatever you have here, cos 30. Because you place the unbalanced parameter vertically. You understand me or not? This one, yeah, no longer 2 theta, is cos 30. Because you place this one, cos 2 theta, what be given this one? So this one should be 330. So depends. So this FSD, put it there, refer to crank diagram. Do you understand me, class? Anyone? Again, yeah, you have this one. You have cos here. This one you have another sign, so the sign will be cancelled. Automatically cancelling, yeah, for the axial force. So if you go back to the result, you will have the result of this one. Remember this one. This one is due to what you have here. It is not due to this one. It's nothing to do with that. It's nothing to do with that. Yeah, this one is for the this one, put it here, due to what? Crank diagram. Crank diagram. If you put it here 260 degrees, it's not correct, yeah, because only 30 degrees which is not balanced. The 60 degrees basically for the V notch. Remember that, yeah. Okay, last but not least, we are talking about secondary reverse now. Secondary reverse. I'm going to share with secondary reverse. Crank. 1, 2, again 30 degrees, another 30 degrees, couple of minutes, yeah. We will close our session today, yeah. So this one is secondary reverse crank diagram, where you find that your 2 theta is equal to negative 60. Excuse me, yeah. So this one is results. This one is omega. This one, put it here 2 omega. You look at here. Sling number 1 move 2 segment for primary direct. Another 2 segment here. This one is primary direct. This one is secondary direct. Correct. For secondary reverse, this one is equal to 60 degrees. This one is equal to 30 degrees. So for secondary reverse, so it will move also 60 degrees, isn't it? From this one. So 60 degrees. This one is secondary reverse, also negative 60 degrees. So 60 by 60 by 30 become 90. Cylinder number 1. Understand? Is that understand? Is that clear? Anyone? Anyone still with me? Let me check how many of you. You have 46 candidate here with me, yeah? Okay, now thank you, yeah. Those who are responding, thank you very much, yeah. You are not leave me alone here. I'd just be talking to myself here. So another one is I'm going to focus only cylinder number 2. Number 1 done. This one is omega. Look at number 2, huh? Look at number 2, okay? Let me check this one. Okay, number 2. This one, remember just now, 30 degrees, 30 degrees. Cylinder number 2 move 330 degrees. Right? For prime, this one primary direct. Secondary direct will move 660 degrees. For secondary reverse, will move 660 degrees also, isn't it? So now it will move. Let me change another color here. So you'll be getting as such reverse. Make it 2 complete circle. This one up to here, you'll be getting 720. You only want 660, isn't it? So minus by 660, you'll be getting 60 degrees. 60 degrees will fall here. 60 degrees. So 2 will be here. Isn't it? So your secondary or fourth secondary reverse is equal to 0. So if you go back to here, you found that it is balanced. And you add up together, you'll be getting this one. And not, it is not a stop here, yeah? Well, you have to add up together primary and also secondary. And finally, you become as such. So this is 9491 force. You have to convert to become what? To become mr omega square. This one constant, this one representing the 941. This one constant because running with the speed, just know what? Running with speed 1000 RPM, for example. So what you need is R. So if you can, let me stop this one. Let me stop this one. I'm going to share with you the solution from the animation. So look at here. So the unbalanced parameter, what you have is this one. Look at here. This one is not very clear because we have a darkened one. This one. Look at it. If you can see the darkened part, and this one is much clear. The green one, 2-sided green one, only focus for 2 cylinders because we are talking about twin cylinder just now. Okay. So now I'm going to stop sharing this one. I'm going to go back to the slide earlier. Any question before we move to this one? Because for the V engine, it's not only for the V twin. Sometimes maybe you have V8, V12, for example. Currently, we are focusing on most of the the automobile manufacturing, yeah, or engine manufacturing manufacturer. Now focusing on V12, for example. Okay. You know, if you have V6, for example, you will have how many crank? How many crank you have? Common crank. How many common crank you have? V6. Anyone? Anyone? Am I talking to myself here? in 1 class 3. If you have here, you have what? You have 8 cylinder. Tell me how many common crank you have? 8 cylinder, you have 4 common crank. How many bang you have? How many bang you have? You have common crank, yes, 4 bang, 4 bang. Put it there, 4 bang and 4 common crank. So the question here is they provide you only the first bang. This one is bang number 1, for example. Yeah, bang number 1, which carries cylinder number 1 and cylinder number 2. And the position of the crank is located at the top. If supposingly we mention this one as 0 degrees, so this one at 0 degrees. You understand me or not? So if your eye sees here, from side view, you are focusing on, if I can share with you, you are basically looking at a crankshaft. A crankshaft, this one. Wait, quick one. This one, if I put it at 0 degrees, this one is a 90, sorry, it's 180. So this one will carry number 1, number 2, bang number 1, crank number 1. Bang number 2, look at the equation. What the position for bang number 2 is 180. So 180 will fall downward. So 180 will fall here. So it carry number 1, number 3, and number 4. Bang number, this one is bang number 1, bang number 2. Bang number 3 at another 180. Bang number 3 also another 180, another 180. Bangs 1, bang number 3. B3, B2, B1. The CC1, CC2, CC3 is also carry another cylinder, 5 and 6. The last bang, which on 0 degrees, will carry the last 2 cylinder, 7 and 8. So it will be pointing upward. You carry another one here. This one be cylinder number 7, number 8. This one be bang 4, and also common crank 4. Okay, but the question is now providing you only one bang, bang number 1. So you refer to this and use this one, use this as guideline. GUIDE as guideline. Use this as guideline. So the guideline means that you are going to use this one. You're calculating everything as what we did earlier for the twin cylinder. You add up together all the forces. Then you make the forces for the crank number 1 or bang number 1. So stay with me. Yes, we are going to this one. The position. This one look nicer, isn't it? Bang this one. A, B, C. This is the distance or space between bang to bang. This one is not cylinder to cylinder. Yeah, this one bang to bang. Okay, look at the position: top, bottom, bottom, and top. 0, 8, 1T, 1T, and 0. So our work will be constructing or following this one, and we are going to focusing only here at the bang pointing upwards. So now we start with this one. Okay, I'm not going to do this one in detail. We have done this one just now earlier. So this one you found that it is balanced, isn't it? So sorry, it's not balanced because primary direct. So you have the result is this one. This one now is pointing downward. Look at here, pointing downward. You will have force pointing downward. Then you have sine 30 degrees. Or you can also use, if this one 60 degrees, cos 60 degrees. We have this one pointing downward. You add up together, one pointing upward, one pointing downward. Because we are dealing with vector, you have this one pointing upward for primary, first primary. You do the same thing, the same procedure for the secondary. Here, cos 60, because this one 60 degrees. You have this one 884.3 pointing upward. Do this one the other time, this one pointing downward, this one is cos 180. Why cos 180? Because at the very beginning we say this one 0 degrees, this one 180, cos 180. You will have as such. Okay, you add up together in vector, you found that you'll be getting 884.3. Then finally, what you have to do now is to add up together all the forces, typically for the primary and secondary. And finally, you'll be getting this one, pointing out. But remember this one for what? For bank A just now, or common crank A also. Isn't it? For bank A or common crank A. Or perhaps put it here, not bank A, put it bank 4, easy. Sorry, bank 1, bank 1. Common crank A. One, because they put it A just now. Okay, now put it there. Same thing for this one. This one is pointing downward. You have to do 2 times, yeah? Because one pointing upward and one pointing downward. Then we're representing the other bank. So pointing downward, you have as such. You have as such, you have this number pointing downward. You do the same time for primary. You have this one pointing downward. Then you add up together, you will have as such. Remember this one is bank 2, isn't it? Pointing downward. Okay, now you have what? 1 pointing upward, 1 pointing downward. The rest will follow. The rest will follow. Then this one will belong to this one, will also belong to here. So what I'm intend to share with you, this one is easy. Look at it, I'm going to share with you much challenging, yeah. 1 minute, yeah, before we end. I need to finish up this one before we end our lecture, yeah. This one you have animation with you. After completed this one, and look at there. You've done this one and just isn't it? Then you have the numbers. 1 pointing upward, 1 pointing downward. See, this one and this one pointing downward, you have the same result. This one pointing down, you have the same results. Okay, then you have to do what? Because you know that you have the distance, or you have the length or the space between one bank to another bank, so you have to do the moment. Do the moment. You will have, finally, you begin the moment here. The unbalanced couple acting in this one. This one you understand, yeah? So if I can share with you another one, yeah? Stop sharing so that I can share with you the earlier part of the solution. After doing this one, you do this one. Then how are you going to explain to balance the engine now? You go back to the earlier part of the engine. Remember, yeah, this one only for bank number 1, isn't it? So bank number 1, this one, you have what you have here is basically, if you can put here numbers here, 1 pointing just now, pointing just now, pointing here, and pointing here. And finally, you know that when you calculated the thing, it becoming the result of this one. This one, you have the force equal to 3.5, and the unbalanced force acting on the engine frame is 3.5.6 pointing downward. Negative, this one pointing downward. So it is pointing downward. What does it mean here? You have to do something about it on creating or constructing the crank which is pointing upwards. Isn't it? Correct? Or you can do individually. You can also do, yeah. So this one is the total one. This one is the total force acting on the system when you have so many banks. So therefore, the unbalanced couple in acting in the frame engine is 1,000 or 1 kilonewton rotating clockwise. So all these forces will be. This one can be balanced. This one is very difficult for you to balance. Yeah? Because you have a moment here. So what happened to the moment now? There is so when you found that when you want to construct or perhaps you want to design the supporting what you call it, the mounting of the engine, yeah, we call it bush, BUSH, the mounting of the engine. You need to know which position of the engine, because the bearing of the mounting of the engine is not the same. Whether it is left side or right side, it is not the same, because the bearing will be counter or perhaps withstand all the couples and also the what do you call it, the secondary force. to ensure that the system of the engine will be running smoothly. Okay. So I think that's about it on the reciprocating engine. So when I meet you again, inshallah, I'm going to talk about the latest note that I provide you this morning on the fluctuation speed energy. So before we close this session, is there any question that you want to ask about this topic, class? Any question? Lynn, any question, Lynn? Any question? No? Okay, thank you. So if there's no question, I'll be seeing you again, inshallah, tomorrow morning. Yeah, tomorrow is Monday. Tomorrow morning at 10. So I'm going to give you instruction on the fractional spin energy. So please read the notes. I provide you very early the notes, so 1 day or 2 days before the lecture, so you can read on your own. Then easy for you to digest in class and during the class time. So with that, I end my session with Assalamualaikum warahmatullahi wabarakatuh. Please stay safe and stay healthy, class. So we see you again, inshallah, tomorrow morning. Thank you, and have a nice day. Thank you.